Welcome to Module 6. You'll notice things look a little bit different for this module. I brought in another computer from home. Hopefully this computer will work a little bit better than the last one that I've been using. Won't be quite as herky-jerky on the video. Last week I talked about the vector model and geoprocessing and vector analysis. So we went through a lot of stuff last week. It was points, lines, and polygons, and maybe topological relationships between those things, and how you can link the spatial information to other aspatial information that we're going to call attributes using relates or joins, and then how you can do things like selections and queries. You can query by attributes, query by location. And then there are these higher level functions called geoprocessing tools that you can apply that do things like vector overlays, clips, buffers, things like that. And when you chain these geoprocessing functions together into a workflow, you can accomplish a pretty complicated vector analysis. So after that module, you're probably thinking, I'm glad we're done with that vector analysis stuff. But I want to say not so fast. There's a couple of things I want to include that I haven't talked about yet that are usually very popular and valuable in doing vector analysis, and one of those is field statistics. So you have the spatial data, points, lines, polygons. It's attached to these attributes or fields, and you can apply field statistics to those fields to get information about the attributes that are in your feature classes that will help you make decisions or answer questions that you have. So there's two basic types of field statistics. You can do summarized field that works for all kinds of data, NOIR, the categorical in addition to the numerical data. You end up getting a table that has one row for each unique value of a specific field. Field statistics was only going to work for numeric fields. So if you have numeric fields, you can use field statistics, and it'll give you some of the descriptive statistics for all of the features that have numeric values. Okay, so summarize. This one is best with categorical data, which would be nominal and ordinal data. In this case, an example, I have a data set of cities, and I'm looking at the field called city name. City name is going to be nominal, right? A name is, there's no numbers associated with the name. And I'm going to create a table that tells me about the population 1990 field that's inside of that table. I'm going to get the minimum, the maximum, and the average population in 1990. Okay? So here's the results of that summarized field. So I have this data set that has a whole bunch of cities. It turns out, just like you might think from The Simpsons, that Springfield, there are 9 cities called Springfield in that city's data set. So there's 9 different cities that have the name Springfield. Okay, the smallest city with the name Springfield has 11,000 people. The largest city has 156,000 people. And the average population of all the Springfields is 65,000. So here you can see that by doing summarize based upon city names, a categorical or a nominal field, I'm able to get information about these things that have textual or nominal values. Okay, if I've got numeric data, let's say I have another city's data set and I have a field that's population of 1990. Since that's a numeric field, I can ask it to give me statistics for that field. It's going to go into that field and it's going to count all of the features. So there's 3,149 cities in this table. The smallest population was 8,200. The largest population was, it looks like, 7.3 million. And so the total of all of the populations was 143 million. The average population, 45,000, blah, blah, blah. So you can see that it's going to give us descriptive information about any numeric field that's in our table. Also gives us a histogram or a frequency distribution. And here in this case, you can see that most of the cities are smaller, and then there are a very few number of cities that have larger populations, kind of like you would expect. Calculate geometry is another one that's really valuable and useful. What that does is it populates a field with some type of geometric value. Depending upon whether you have points, lines, or polygons, you'll be able to populate it with different types of numbers. So you can add a field to your attribute table, and you can calculate geometry and tell it, I want you to tell me what the area is, or the x coordinate, or the y coordinate, or z coordinate, such and such. So for points, you can have it calculate the geometry of the x, the y, or the z if there is a z coordinate. With lines, you can have it calculate the length of the line, or the coordinates, the x, y, z, of either the start, the end, or the midpoint. And if it does have elevation associated with it, you can have it calculate the maximum and minimum elevation of that line. For polygon, you can have it calculate the area and the perimeter, and then again the coordinates, but this time it'll be of the centroid of that area. And if there's a maximum and minimum or an elevation attribute associated with it, you can get the z max and the z min. So this is how you get information out of that shape field into numeric fields that you can look at and analyze. So you can get the coordinates, get the numeric values of the geometry out of that field that just says shape. Here's a few examples. I've got a point, so you can see I can get the x and the y coordinates. So if I get a new field to my table, I right click and I do calculate geometry, it'll know it's a point, it'll give me these options. You can do lines, you can have the length of the line, or coordinates of points or midpoints. And for polygons or areas, you can get area, perimeter, and the coordinates of the centroid. None of these have elevation information. If they did, options would allow us to get coordinates of the elevation or maximum elevations. So those are just two of the other functions you can use on your vector data to get information that you might be able to apply in an analysis. So really, I've just kind of scratched the surface of what you can do with your vector data. And when you look at the toolbox in Arc Toolbox, if you go to the analysis tool set and you go in here and you look at all of these tools that are included under analysis tools, you can see that I've covered some of these in the videos that I've talked about, but there's some that I haven't even covered. And in addition, there's boatloads of other tools. There's hundreds of tools out there that will do really valuable things under certain circumstances. And so one of the keys with learning how to use GIS and how to become a geospatial analyst is figuring out where these tools are and what they are and how to use them. And so one of the best ways to do that is to use the search bar. And the search bar is available. And if you have kind of a grasp of terminology, or what we might call the vocabulary of GIS, you can just type in a word that you think might apply. So in this case, I'm thinking, I've got two data sets, I want to combine them into a single data set. I have a data set for Idaho and a data set for Washington. I want to put them all together and just have one data set. So maybe there's something called merge that will merge them together. You can type the word merge in and click on this tool link right here. It'll go out and it'll search through all of ArcGIS and it'll give you a list of all the tools that have the word merge in it. And you can search down here through all these tools and you can see that the second one down says merge combines multiple data sets. Oh, maybe that's the one that I want. You can click on the top line here and it'll actually run the tool for you, or open up the tool window. If you click on the second line, it'll give you help on what that tool does. So if you're not sure if that's the right tool, you can click on the second line. It'll give you help information. In this case, this is the tool called Merge. It's in the Data Management Toolbox. It has a graphic showing you what kind of things Merge does. And if you could scroll down, which you can't here, it'll give you more information about how to use the tool. If you decide you want to use the tool, you can run the tool. In this case, the tool looks like this. You just basically tell it which data sets you want to merge, what you want to call the output. You can do some other optional things, but those are the only things you need to do. Run the tool. You can merge multiple data sets into one. So remember, think about the terminology, think about the vocabulary, use the search bar. Once the search bar finds something that might fit, look at the help system, see if the help system tells you that it's what you want to do. If so, see how to use that tool, and then go ahead and use it. So then you can access these hundreds of tools that will do a lot of things. And a lot of these tools were developed specifically for people that had problems that they needed solutions to. So a lot of the tools are really valuable. Okay, so I think I'm going to leave vector analysis and the vector model a little bit behind now, and I'm going to move on to what's called the network model. It's going to use vector data, but it's looking at vector data in terms of topological relationships so that we're able to get from one place to another using a network model. So that's going to be what I'll introduce in the next video.